Welcome to SolidityATL's Web3 Security Session 4. In this session, we're going to go through a few things. In the first module, we're going to talk about Web2 Security. In the second module, we're going to talk about Web3 Security, so we're going to intro both of these topics. In the next one, we're going to talk about becoming a blockchain security expert. And then in the last module, we're going to talk more about smart contract development frameworks. We're going to touch a bit on application security or web app security. This is also called AppSec. Then we're also going to talk about phishing and social engineering. Next, we're going to talk a little bit about DNS and DNS takeovers, Discord hacks, private key thefts, and then SIM swapping. All right, so to start off the application security, this is essentially centered around what we call AppSec. So that's application security, AppSec for short. And application security can be categorized as bugs within the front-end code that can impact the functionality of the app. So when you think of an app like MetaMask, for example, that's an application, and there's front-end code that's involved with creating that extension. So there could be potential bugs within that front end, right? So when you take any app, it could be MetaMask, it could be Facebook, whatever it is, that's front end code, and there could be bugs in that code. And people who work in the application security space or the AppSec space are experienced at finding bugs in that code. So I know many of you know about smart contract auditing, but there is a similar format or similar process you would follow for auditing a web application. It's typically called a security review, or pen testing, or front end testing, or stress testing. But this is what AppSec entails. Now, a big important part of AppSec is understanding and knowing the OWASP top 10. So OWASP was a standard that many cybersecurity professionals use for AppSec and understanding what are the main bugs that impact their environment or their web application. So we're going to be going through a few of these, but for now, we can talk about the top 3 that you will typically see in the OWASP top 10 for 2022, I believe. So at this current state, broken access control is the top bug typically found in applications. Next, we have cryptographic attacks. So as we know, there's cryptography also involved in many applications. It's not just about blockchain-based apps that use cryptography. Many apps store keys, or you think about API keys. There's cryptography used in many parts of an application. So that's another example of an attack that can hurt or hinder your web application. And then we have injection type of attacks. So this is more so talking about SQL injections, as well as content injections. So like we said, we'll probably go more into detail on OWASP top 10, but just wanted to give an overview of what application security is, and then also an example of what are a few bugs that you may find in a web app. All right, let's talk about DNS and website takeovers. So attackers can manipulate how DNS queries resolve, redirecting users to malicious websites. So when we think of how a website is hosted, there are DNS queries that have to be resolved whenever you click, let's say, facebook.com, right? So you're going to have DNS queries that get resolved, and then content is displayed or viewed to you that matches the queries of that website. So let's take a look. We have our client, which is your computer, your DNS server, and then you have your example server, which would host the content of your website. So when a DNS hijacking attack occurs, what's happening is those contents are spoiled, and the DNS server is pointing to a hijacked DNS server, which means content from the attacker will be displayed back to the user. So an example of a recent DNS hijacking or website takeover was Balancerify and then Galax. I believe that's Galax. They were attacked by scammers, hackers, however you want to call it, and their websites was displaying content that was not original to Balancer and Galax. And once exploited, the websites usually contain malicious smart contracts. So when we talk about, this is now, I know we're talking about Web 2. Let's shift our brains and think about Web 3 for just a second. When you host your dApp, you're still using a website. So you're still sustainable to a DNS hijacking attack. So whenever this typically occurs on a Web 3 dApp, the website usually contains content that's pointing to malicious smart contracts. So, for example, if I were to perform a DNS hijacking attack on Uniswap, I could have malicious content shown to anyone who visits uniswap.org, and that would allow people to interact with this malicious smart contract, maybe depositing into what they think is actually a pool or performing a swap, but at the end of the day, I'm just draining their wallets. So this is something that's very important from a Web 2 and a Web 3 standpoint. All right, next we're going to talk about phishing and social engineering. Now, phishing is the fraudulent practice of passing off as a legitimate company or person to steal important assets. If you're familiar with your company's policy, if you've actually taken your security test, you have likely gone through some form of phishing and social engineering training. You know, those tests that give you a fake email and ask if this is social engineering or not. There's also companies that phish people on purpose. So what they do is they send you what would look like a malicious email and record who clicks on them. So you may have been through one or two of those processes to teach about phishing and social engineering, but that's the most important thing you need to know about phishing and social engineering. People are passing off as being legitimate to steal something from their victims. Let's talk really quick about how this is an issue in the Web3 space. We're going to talk about a Twitter phishing example. So we take a look over here. We can see that this is a phishing attempt. What this user has done, or how this user is playing people, is they first have a verified account, so they look legit, and they have an ad, like an ad that they're pushing out. So you may think this is a legitimate site, but you may not know. But from my point of view, I understand that this is a fake BittyKnots minting site. So BittyKnots was a project that had a legitimate mint, but a lot of other projects ended up trying to use them as a way to scam people, essentially. So maybe we can look at BittyKnots. Yeah, so this is what it would look like. So even then, let's make sure this isn't the phishing site. All right. So yeah, we can confirm. So it's important to just understand that you have various collections, and people may try to pass off as the legitimate project, and they will end up stealing your money if you click on this link and try to interact and mint that what they're saying to be free, but they're taking your money. So another example is a social engineering example we're going to run through here. Many Web3 scammers will try to get people to install malicious malware on their computers, in light of trying to help them. So in this one case, shout out to NFT Drew. He talks about an example where a Mutant Ape Yacht Club holder joins the Bored Ape Yacht Club Discord and essentially tries to social engineer his way into making over $100,000 worth of Bored Ape Yacht Club tokens, or NFTs. And so I'm not going to run through this whole example, but long story short, Samuel tried to get people to download some malicious software. They tried to set up something, like this Blur NFT Sniper. So they try to get you to download something to your computer, and then they may try to hop on a call with you to screen share and take over your computer to do something malicious. At the end of the day, you should not be downloading things people tell you off the internet. You need to do your own research and make sure that whatever you're about to download is legitimate and it's authentic. And if you don't know, there's a huge community of security researchers out there who you can simply ping, I being one of them. So if you have any questions, if you're in this course, definitely drop them in the Discord if you are curious about something. But it is your job to learn this information and to go out, spread this knowledge, and make sure other people are not falling for these scams. All right, so next is SRP and private key theft. So SRP, for those of you who don't know, is secret recovery phrase. This is what is typically used to recover your crypto assets on most of the modern day wallets. So a very important thing that you need to know as a security researcher is your SRP and your private keys are very, very important. You should not be letting these get out in any type of way. You should not be writing these in password managers. You should not be having them online in any way, shape, or form. Your SRPs are supposed to be private. Now, I will say it's okay to have your SRP or private keys on a password manager if you are okay with the funds for that wallet being lost. Let's say you only have, a test wallet or a wallet you just do simple transactions with that maybe, let's say, under $20. Depending on your risk level, if that is something you're okay with losing, it's okay if you have that SRP or private key in a password manager. Another thing that's important is that your SRP is for multiple wallets. So if you have, let's say, 5 different wallets that have $50 each on each of those wallets, your secret recovery phrase will allow you to recover all of those wallets. Your private key is attached to just one of those wallets. So as you can see or imagine, your SRP is very, very, very important. Another thing is that all of the assets on one wallet are at risk of being drained if that private key gets out. Essentially, another person can recover your wallet or import your wallet and spend that money or send it to a wallet that they own. So this is a very important thing to understand if you are a security researcher. I know many of you may be coming from the Web2 space and aren't too familiar with private keys and secret recovery phrases. These are one of the most important things you need to keep safe for the projects you're working with or just for yourself in general. We'll probably get into some mitigation strategies for dealing with your secret recovery phrase and private keys in the future, but I think for now, the biggest thing is if you are advising a project or protocol that's using, obviously, crypto wallets, make sure that they're incorporating multi-sig wallets with their deployment contracts, with any of their admin-based contracts. A multi-sig wallet should be used because you need multiple people, hence the word multi, and multi-sig. You need multiple people to have given their approval or authorization to perform a transaction. So you may need 5 out of 6 people within your stakeholder committee or 5 out of 6 of your developers to approve a transaction before it's done. This is one of the most important things you can do for preventing private key theft. secret recovery phrase, that would be a little bit different. But again, like I said, SRPs should not be online. If you are managing SRPs for a project, these should be written down somewhere and kept in a safe place. And when I mean safe, I mean a place like a safe that is fire and water resistant in case of some type of emergency. All right, a very important topic regarding Web 2 and Web 3 security, in a sense, is SIM swapping. SIM swapping is when attackers use your identity to gain access to your phone number. They do this because your number allows you to access sensitive accounts. So, for example, when you're logging into your bank or maybe Coinbase, once you enter your password into a site, you are then able to, you then must enter a one-time passcode. So, this is essentially what, what SIM swapping looks like. The user is targeted by an attacker. They collect as much personal data as possible: name, obviously, number, date of birth, location, and they can use these things to impersonate you when contacting your mobile provider. And what they essentially do is say, hey, I have lost my phone, or it was stolen. I need you to transfer my SIM over to this phone I have. And that attacker has another device they're using to be the new phone, which is going to have all your data on it because they're going to have your SIM. And so what they do is they may have already had your passcode in a data breach or whatever it is. Use your passcode or use your password to log into a bank account. And whenever they're given that one-time PIN, they are able to use that one-time PIN to access your bank or Coinbase or whatever app or DApp it is. And an important case to know, or some historical lesson to know, is when Vitalik was SIM swapped, resulting in victims losing over $700,000. This was a fairly recent case that definitely is going down in the books of Web3 history, because this is Vitalik, the founder of Ethereum, was SIM swapped. And he practices a lot of great security. He practices great security, but in this case, there was a slip up. There was a mess up. I believe his number was tied to his Twitter account, and that's something that people had been saying to remove off of your Twitter account. And these scammers was able to SIM swap him and post tweets on his behalf, which led to people interacting with malicious smart contracts, thus for losing $700,000 worth of money. Okay, in this next module, we're going to talk more about Web3 security. So we're going to touch on what is smart contract security, talk about smart contract security history, describe the life cycle and the different stages of auditing, and then talk about private key management and some best practices there. Okay, so what is smart contract security? These are activities that ensure the smart contract code is safe, secure, and performs its intended actions. The difference between safe and secure here is when we say safe, we're talking about, is this project a rug pull or not? Is it safe for users to even be using this product to begin with? Many times when we audit code or we work with different clients, you can tell if the clients you're working with are scammers in a sense. You can tell if what they're doing is solely just to drain users of their crypto and their money. So that's what we talk about when we say, is this project safe or not? Now, when we talk about secure, we're talking about security, auditing the smart contract code, making sure there are no bugs in the code, and then also performing its intended actions. Is the code doing what it's supposed to be doing? Next, we want to talk a little bit more about security reviewers. So security reviewers or auditors audit or review this code of smart contracts, attempting to rid them of bugs, making sure invariants are checked for, and like we said, this code does what it's intended to do. Now, a lot of people in the space will say, security reviewer is better than audits, and security audits is better than security reviewer in terms of the naming and the nomenclature. This is really, you can choose whichever one works for you. People will want to go with, I'm a security reviewer, we're doing security reviews, and you're just going to have the people who want to say they're auditors, which is perfectly fine. Next, anyone can contribute to a protocol's smart contract security, even if you are a user who is not interested in becoming an auditor. The reason for that is you can put pressure on a project you're working with to make sure they're ensuring the security of their project or protocol. You can be in the Discord, you can be in their Telegram. Anyone who's a part of the community can simply ask the questions. Has this code been audited? What are you guys doing to focus on security? What are the steps you're taking to make sure your users are safe? So it's important to understand a little bit about the history of smart contract security and understand at least the eras that we have been in the Web3 space. So after the first major hack, the DAO hack, security started to be taken more seriously. You can go and research more about the DAO hack yourself and understand how this was performed, but essentially it was the very infamous reentrancy attack that caused so much craziness and stress within the Ethereum space when this happened. A lot of money was lost, and this actually ended up resulting in a fork from Ethereum Classic. So won't go too deep into that history, but it's important to understand that security started to be taken a lot more seriously after this hack occurred. And from this point on, from 2016 to 2021, I will claim this, or we're going to claim this as the audit shop era. This is what we're going to call it. This is where companies like Open Zeppelin, Trail of Bits, Consensus Diligence rose to their popularity by selling their services by essentially auditing various protocols. So this was the audit shop era. At this time, audits were extremely expensive. They were backlogged for days and months on end, and there honestly wasn't a lot of people who were in the smart contract auditing space at this time. Now, from 2021 to 2022, and I'll say, currently 2021 to now, contest became the new thing within the smart contract space, or the smart contract security space. Companies or communities like Sherlock and Code for Arena made these bounty contests very, very popular. Also, we'll throw in Immunify as well, because that was essentially a bounty platform. But this is where bounty contests, bounty hunting for smart contract security started to get very important, and a lot of people started to join the space. Now, from 2023 on out, we'll claim this as the independent security researcher phase or era. After working with companies during contest, it became popular for the top earners and the top auditors to essentially take the business for themselves. Why pay all this money for this pot if you can pay much less to 2 or 3 auditors who are the best in the space to audit your protocol? So 2023 on out is where the independent security researchers started to boom. We got folks like Pashav, Bytes, and TrustX, and now Cifrin, and there's even though some of these have turned into audit shops or smaller audit shops, they still have a specific focus now. They have independent security researchers who have specialized talents in certain areas and are now being contracted out to work with the various companies. So it can be compared to we're starting to go back to the audit shop era, but I still think that these are really, a lot of them who are working in these small audit firms are like independent security researchers. Also, we'll talk a little bit about Spearbit. Spearbit has independent security researchers that can get paired and matched with various companies or protocols. So 2023 on out is the independent security researcher movement and era, and we'll see what happens after that. Maybe bots will take the stage, or AI will take the lead in 2024, 2025. Who knows? But it's important that you understand a little bit about the history of smart contract security and the history and background of smart contract auditing. So next, we're going to talk about the audit stages in the audit lifecycle. So when we talk about audit stages, we're talking about if you are a company or protocol and you're looking for audits, what would that essentially look like? And also, it's good to know from an auditor standpoint, what are the different stages you should be recommending to the clients or the people you're working with. Next, we're also going to touch on the audit lifecycle, so what typically happens from start to finish when you actually perform the audit itself. This can look a little bit different depending on the audit stage you're in, but we're going to mainly talk about dealing with private audits within this audit lifecycle. All right, so let's talk about the audit lifecycle first over here. When you are working with a client or a protocol, however you want to call it, there's going to be a life cycle for how you first interact with the company or the client, and then how you deliver your deliverables. So first thing you're going to need to do is get the code and plan a quote. So that involves receiving the code from the protocol and then determining how long you're going to take on this protocol to audit it, as well as how much this is going to cost. Now we're going to let you be we're going to let you decide how you want to, plan out this quote. People may do pay per vulnerability. People may do pay per hour. Some people do free if you are newer into the space to get in more clientele. So we're not going to talk a lot about that, but we just wanted to highlight this overall life cycle. Next, you're going to identify the vulnerabilities. That's the actual auditing piece. And then you're going to prepare a report. This is very important because preparing a report is crucial for the development team to understand what are the bugs and how to fix these bugs. If you are a fantastic auditor, but you're bad at reporting, you're not going to have a great time dealing with clients, dealing with developers, because reporting is very important. So we want to make sure we highlight this piece as well. Next, after you give the report to the developers, usually they're going to have a stage where they may fix some of these security vulnerabilities and patch them. It is going to be your job within, however you want to create it, but within the next 2, 3, 4 weeks to re-audit this code to make sure they didn't implement or reintroduce more vulnerabilities into the code. And then lastly, the team will either choose to deploy to the network or choose to get another audit. That is honestly up to the team to do. But that is just going to be the next phase of after a code has been audited. So this is the audit lifecycle. This is typically what you would do as an auditor. That is what your day-to-day looks like. Now let's talk a little bit about the auditing stages. So first and foremost, if you're a developer watching this video, it's important that your team does an internal audit or internal review. In traditional companies, you will have code reviews to make sure that the code you're deploying is, solid, sound, doesn't have bugs. This needs to be adopted within the Web3 space. I know many people say we're just going to ship, move fast and break things. That's fine and dandy, but an internal review should be a part of this moving fast and breaking things. So this is an internal audit. This is done by the internal development team. Next is typically when you bring in a private auditor. You may bring 2 or 3 guys in to review this code for however price you want to make it. This is essentially like that first pass through to make sure there's other eyes on this code. Next is typically the bounty contest. So when we say this, we're talking about Sherlock or Code 4 Arena. This is essentially carving out a 2 or 3 week time period and contributing some funds to pay contestants to try and break your code. This is a great way to get a lot of eyes on your code, and it can be honestly more cost effective in some cases. And after this is done, and after maybe you have deployed your code, you've gone through 3 reviews: your internal, your private, and your bounty contest. After this, you may or should make a deal with Immunify to get your code put on their bounty platform, so that at any point in time, if somebody finds a bug in that live code, they can come to your project and say, hey, we found this code, and then you can pay out however much you're willing to pay. So these are typically the auditing stages. Honestly, some people don't go through any. Some people may go through 2, may go through 3 or 4. It is up to you to figure out your approach. At the end of the day, you are going to be responsible as the developer to make sure your protocol is secure. And then as an auditor, it's important for you to know all of these steps, because each of these steps you can potentially work with, whether you want to be a developer yourself and do internal audits, or if you want to, specifically focus on being a private auditor, specifically focus on bounty contests, or focus on live code and breaking those. So these are all of the audit stages and audit life cycles that we wanted to introduce to you all. Then we'll move to the next topic. All right, so we want to finish off with private key management. It's very important that you understand that private keys are one of the most important things you can keep secure in the Web3 in the blockchain space. The reason for that is because your private keys, your secret recovery phrase, literally give access to your money. This is the sole authority that can move funds, transfer funds from your wallet or wallets. So unfortunately, the private key management is not performed at a very great level. There have been many hacks, one of which was the Ronin hack, which actually may still be the largest hack to occur, with a total of 624 million being lost due to incorrect private key management. We won't go into exactly how this attack occurred and do the full breakdown, but essentially, a developer was phished, private keys were lost, and mistakes were made, and that led to $624 million being lost. Like we said, mismanagement of private keys can lead to a significant loss for a protocol. I believe just recently there was a deal with Phantom Foundation where one of the developers they were phished. Supposedly there was a 0-day. Don't really know just yet, so maybe shouldn't be talking about it just yet. But essentially, it was probably a private key issue. Who knows? But the issue here is that we need to make sure that our private keys are managed appropriately. Don't store your private keys on password managers, especially if you are a project or protocol owner or deployer. These are just simple things that should be followed. Now, in terms of what should we do, what should developers do in terms of private key management, make sure you're incorporating multi-signature wallets. If you are an admin or stakeholder, multi-sigs are the savior for private key management. The reason for this is because you need a threshold of users to be able to unlock this wallet or to send a transaction. So in this example, we have a 2 of 3 multi-signature wallet, which means we need 2 people out of the 3 to give approval for a transaction. So in this case, Justin and VT signed. Craig did not sign, but because it's 2 of 3, we are able to use this transaction. So it's important, if you are a deployer of a project, if you have any admin locks on your protocol within your smart contract code, you should you should be using a multi-signature wallet. The reason for that is if there needs to be a change, a high level or privileged change within your protocol, you can have multiple people within that protocol give that authority. Now, if you just leave it up to one person, let them get phished, let them lose their private keys, however the private key is lost, you now have just wrecked your own protocol. So this is very important that we understand, use multi-sigs for private key management, but also at the same time, if you do have private keys, don't just leave them on a password manager. Make sure you're storing that correctly and you're being very conscious of where your private key is placed. All right, so next we're going to talk a little bit more about becoming an expert in the Web3 space. This is something that's very important because we have not jumped into smart contract auditing specifically yet. We haven't jumped into some of those skill sets you need, but we want to make sure that you're set up with all the information you need before jumping into this. So we're going to talk about tapping into the Web3 security community and the Web3 community at large. We're going to talk about the fundamentals you need to know, such as Ethereum, DeFi, and programming fundamentals. We're going to talk about the mindset you need to have. We're also going to touch on finding your niche within this space, and then also optimizing your process, your audit process, your learning process. Very important that you learn how to tap into the Web3 security community and the Web3 community at large. First, you want to make sure you're watching all the basic Web3 security videos. Watch Patrick Collins' videos, watch Andy Lee's videos, watch the Smart Contract Programmers security videos, and then Owen Thurm's videos. And sorry if we're missing you and you're in the space creating videos, creating free content for people. We'll definitely drop those in the Discord. But these are the base level of the videos you need to make sure is in your rotation and things you're watching. Next, you're going to want to follow auditors and security researchers on Twitter or X. There's Pashav, there's Bytes. These are the main, there's plenty more, of course. But these are the main ones who essentially focus on posting daily. And, at the time of recording this, they were, maybe when you're watching this, may not be. But these are the auditors you want to follow on Twitter, and then follow the people that they are following. Next, you're going to want to make sure you engage with different Discord communities. We have our own with SolidityATL, but there are Discord communities like Securium, like OpenSense, and I believe Owen Thurm also has Guardian Audits. There are plenty more Discord communities you will learn, and ones that will drop in the Discord. But this is important that you get connected, you get plugged in, you're reading, watching this community's content on a daily basis, because this is going to help you learn to be a better auditor. You're going to learn the best tips and tricks. This will put you ahead of the layman person who's just curious about Web3 and decides they want to learn. You literally submerging yourself in Web3 security content and people every day it's just going to in turn make you a better auditor. All right, so you're also going to want to master the fundamentals. We talked a little bit about the fundamentals when we first introed this course, in the session 1 and 2 and 3 as well, when we talked about some of these DeFi principles, opcodes, all these things. It's important that you also do your own research and master these fundamentals to a key. So you need to know the basics and the main ERC, the ERC standards. You need to understand how opcodes work. You need to understand how smart contracts work. So to do this, you're going to need to do a lot of practice. You're going to need to code. This is very, very important. You need to understand these Ethereum fundamentals first before you can really start finding these complex and various bugs. Now we will talk about this more later. You will be able to find entry level and those low severity bugs, but if you want to be a great auditor, these are the things you're going to really have to focus on. Next is you're really going to have to spend a lot of time understanding various DeFi concepts. Things like lending and borrowing, swaps, perps. Again, we talked about these things and we've introed them, but you're going to have to do a lot more research in terms of solidifying your knowledge of these concepts. Lending and borrowing, you need to make sure you look at other protocols, read through their code, understand what they're doing, read through their docs. You're going to have to watch videos, YouTube videos of lending and borrowing, understand the issues in the Web2 space, taking this knowledge and just really making sure you're understanding these DeFi principles. Like we said, same with swaps, perps. These things are not just specific to the Web3 space. They existed within the Web2 and traditional finance world. They're just some modifications to them. So make sure you really learn these fundamentals, read, and then also maybe write some code as well. And to piggyback off of this, we want to talk about programming. You got variables, loops, scope. There's a lot of things you need to understand in terms of programming. So you need to be coding and building things as you go. This is going to make you a much better auditor. So the next thing we're going to talk about is the mindset you need to have when entering into the smart contract security space. It's going to have to be hardened. And what I mean by that is you're really going to have to try hard and grind and do things you're typically not willing to do when it comes to learning about smart contract security. And if you want to be a developer, it's going to have to be even harder. So if you're already thinking about joining this space as a smart contract auditor and you want to excel at it, you need to have a hardened mindset. So first things first is you need to make sure you're focusing on something you're passionate about in this space, or you will face burnout often. The reason for that is there are many other individuals who are driven by this passion that allows them to spend hours and hours learning, growing, and also auditing. Now, there are a few auditors in this space who will tell you that they do it for the money, and maybe that's enough. But what I will say is you will definitely face burnout if you are here for the wrong reasons. To follow up on that, with this hardened mindset, you're going to have to develop a regimen for continuous learning and growth. This is something you're going to have to be doing on a weekly, and in most cases, a day-by-day basis. This regimen will help you become an auditor that can find those complex bugs that can put your hacker's cap on and figure out what are the vulnerabilities in this code that a plethora of other auditors may miss. And then lastly, we talked about this in the last slide, but you're going to have to surround yourself with other like-minded auditors and developers. You need to make sure that you are conversing with other auditors, challenging yourself with other auditors and developers. You need to constantly be working together to maybe do joint audits and learning from each other. There's a saying, iron sharpens iron. And if you are not surrounding yourself with other auditors who have this hardened mindset, you may not go very, very far in the space. And I'm not saying, you won't be able to be successful if you do it alone. It's definitely possible, but it's for sure that if you learn from others, you help others, work with developers, and you really focus on, being in this crowd of other great auditors, you will definitely be brought up the ranks much faster than someone else who doesn't. Another important thing in the Web3 security space, if you're trying to become an auditor, is to find your niche. There are many different areas within the Web3 space that you could propel yourself down. If you are a developer, you have a certain set of skills that someone who is not a developer has. So your approach is going to be different. Maybe in terms of auditing a protocol, you can help them rewrite, or you can do some contract work to be a part-time developer, but you're a security engineer. This would set you apart from other auditors. Similar to if you're familiar with DeFi, GameFi, or identity-based protocols, if you can specialize into these or into one of them, that would set yourself apart from the rest. Furthermore, if you can focus on gas optimizations, there's Discord security, there's traditional pen testing. Maybe you don't know much about blockchain security, but you want to pen test the web apps. There's still a need for this, even though a lot of the data and interactions is having on chain or on the blockchain. There are different components of the website that may be vulnerable. Maybe you're specialized in forensics and incident response or fund recovery. You can also be someone who's focused on education and resources like we are. And then lastly, maybe threat intelligence. So that is basically someone who finds the common threats in the space, and you do write-ups, you teach companies and consult with clients on what threats they need to look out for and what threats they need to build in within their dApps. So there's plenty of different areas that you could focus on, but if you want to excel in this space, you must find a niche, and then make sure you are the best at it, because you'll be building your brand, you'll be building a name for yourself, and anytime someone needs a security engineer who's a great developer, they will reach out to you potentially. So this is not like a one-shot guide or the low all be all. There is room for generalists in the Web3 security space, and the reason for that is just there's still not that many smart contract auditors. So I would say definitely being a generalist is okay, but if you want to excel, again, we're trying to create blockchain security experts. We believe you should definitely be finding a niche. All right, so next we're going to talk about optimizing your process. This is not just specific to your learning process, but also your auditing process. So let's jump into the first one, your learning process. When we talk about your learning process optimization, what we want you to focus on is leveraging note-taking while you're learning, using different methods such as Pomodoros. So if you are not familiar with the Pomodoro technique, that's essentially when you spend 25 to 30 minutes on, which is 25, 30 minutes studying, and then 5 to 10 minutes off, which is resting, doing something that's not related to the thing it is that you're learning. So what most people do, they may go for a walk, walk your dog, stretch, do yoga, maybe meditate. Spend 5 to 10 minutes doing something that's not related to the activity or thing it is you're learning. Another great thing to add to your learning process optimization is mind mapping. That's essentially when you take different categories of the things you're learning and see how they connect. If we were talking about ERCs, maybe you can bunch various ERC types together and then see how they connect to other ERCs or maybe other topics. Maybe you have a bubble that's ERC 20, and then you have another bubble that's DeFi, and then you can link those two together because most of the time ERC 20 tokens are used in a lot of DeFi protocols. Another thing you can do is mixing passive and active learning. So passive is learning that's passive learning is reading, listening, watching. These are the things that you're passively doing. I know that sounds a little confusing, but it's really you're not doing this thing. So that's what active learning is. If we take an example, which would probably be something we should be doing since that's better to explain this, is let's say when you're learning to code, right? You're going to use passive and active learning to learn how to code. Active learning is actually writing programs. You may be learning how to do the simple leap year problem. That is active learning. Passive learning is watching someone else complete the leap year problem or reading someone else's code where they did the leap year problem and you're looking at how they approached it. That is what passive versus active learning is. Next, let's talk a little bit about the auditing process itself and ways you can optimize this. A key thing you should likely be doing is using checklists. This is something that security practitioners or analysts, or however you want to call it, security researchers, this is something that they do traditionally when looking into the security and safety of a platform. You must have a checklist. These checklists can have specific vulnerabilities. These checklists can have different heuristics that are typically used to find various bugs or just to find things within the code. Next is knowing vulnerabilities specific to various protocols and their protocol types. You should know what kind of lending and borrowing bugs are incorporated within DeFi protocols. you should know the vulnerabilities that come with governance type of contracts and governance type of protocols. You should also know the various vulnerabilities that could come up within multi-signature wallets. So these are things you should be doing in your auditing process whenever you are fine-tuning this process, making sure you know these specific type of vulnerabilities for these protocols. And then lastly is how you manage contests and clients. Many people don't know, which contest I should be doing, how long should I spend on a contest, maybe if you're working with a client, time management with that client, how that process should be. This is a very important part of your auditing journey. You're going to have to make sure you're optimizing this process. And we'll probably talk about some more tips for this, but just at a high level, you should not be burning the oil too much when you're doing a contest. And what I mean by that is there's going to be a point in time where your brain is not going to be able to be effective in the contest you're doing. You may want to spend a solid 4 to 8 hours, depending on your personality type. Honestly, you have to spend 4 to 8 hours on a specific contest within a day. And then that may have to be broken up throughout the day. You may not be able to spend 8 hours full send in one go. You may have to cut it up, 2 in the morning, 2 after a short break, 2 hours after going and walking around. You need to give time for your brain to think, and you need to understand that this is how you manage your time when dealing with contests. Same with clients. If you have 2 or 3 different clients, you need to make sure you have the help you need to work with these clients. Are you trying to take on 2 and 3 clients in a week because you're trying to make as much money as possible? Or are you trying to deliver a great quality product so to only really take in maybe 1 or 2 clients and manage the time effectively between both? So this is something that's very important whenever you're learning your auditing process and learning how to optimize this process. In this last module, we're going to talk about frameworks. What we're going to do is run through an overview of Foundry, but we're also going to show you all a quick demo. And we're going to do this similar thing with Hardhat, where we're going to do an overview of Hardhat and then also go through a quick demo. We may also talk briefly about some other frameworks that were deprecated and just give a little bit more history around how we got to where we are today with frameworks. But for the most part, the takeaway from this is you should have an understanding of the difference between Foundry and Hardhat. All right, so let's take a minute to do a quick Foundry overview before we hop into this demo. So Foundry is a newer framework for developing, testing, and deploying smart contracts. In the old days of Solidity, you really had to do a lot of work to deploy your smart contracts on chain. Once you compiled the bytecode, you have to go through a process there, and then you have to go through a process to deploy those. But now we have newer frameworks that help with facilitating all of these activities. Not only just deploying, but also just developing in general, testing, and also fuzzing. So with Foundry, it's newer, it's lightweight, it's fast. It includes fuzzing tools, and it's all in Solidity. So when you write your deployment scripts, this is in Solidity. Okay, when you write your test, this is in Solidity. And then obviously when you write your code, this is in Solidity, and Foundry supports all of these. Now, a con and a negative thing about Foundry is that deploying is somewhat of a challenge when we compare it to Hardhat, which is something we're going to go into in the next slide. But deploying has been known to be a challenge for many developers and auditors. So that is something to take in mind when you are using Solidity. Sorry, when you are using Foundry. Okay, so with Foundry, we're going to run through a quick demo of how you create a project and then just take a look at some of the details about this framework. So in an empty directory, you're going to want to write forge init. Once we let that load, we have all of our Foundry files. This comes preloaded once you have Foundry installed. So let's take a look at some important things. We're not going to cover everything exactly, but what we are going to do is just run through high level. What are some of these features that are included that we talked about? So as we saw, that was pretty fast, getting Foundry spun up. But let's look at this main file that they automatically load for you. So this is a counter smart contract. When we look at our tests, this is how we test our counter smart contract, or this is how we test all of our smart contracts. Something that's important is Foundry comes with some plugins for you so that you can test effectively. So they have this test suite right here, and then also the ability to log some things to the console, which is a little bit different than what you're used to using when you're writing Solidity code. This is, something you're used to if you're a traditional programmer. Excuse me, but to have this console logging ability, just kind of built in with this framework is a really cool feature. Let's just look at how a test is typically set up. So we don't need to run through the smart contract. We're familiar with the layout of creating code, but the interesting thing here is how testing works. So I said things are preloaded, but we have this setup function, which is required. This is how you will set up your smart contracts that you eventually want to test. And then also you have your functions that allow you to actually test your smart contracts. So one thing that's important is you need to make sure all of your tests are abbreviated with test, literally T-E-S-T, test. The reason for that is because if you, let's check this terminal out here. If you were to remove test, and let's say we just made it increment. If we wrote forge test, the only thing that's going to get ran is test fuzz set number. And we can check by looking at this right here. See? Test fuzz set number. Now, we write test back in here. We can see that this is indeed also tested. So that's a requirement. That's something that's interesting for Foundry, but all of your test functions need to have test in front of them. Another cool thing that we talked about is that Foundry allows you to fuzz test as well. So if you could take a look at this test fuzz number, you can see how many times it ran and a few more details about this this fuzzing test right here. So this is a cool feature in Foundry, and you can look up more docs and more videos on how to leverage this, but we're not going to include that in this. We just wanted to kind of run through how does the Foundry test look like. Another cool thing is the ability to, I kind of just demonstrated it, but the ability to kind of see what's happening underneath the hood. So when we wrote forge test and I wrote this dash VVVV, this allows you to see a little bit more, have a little bit more insights about what's happening with those smart contract interactions. So it actually has function tracing, call stack tracing included in these tests. Another cool thing is you have cast, anvil, and chisel. These are other things to allow you to interact with on-chain data. So if you wanted to spin up a local node and interact with your smart contracts on this local node, you can easily do that as well. That's something that's pretty much a standard in the framework process, but that is also offered to you in Foundry. Another cool thing is this is the script right here. This is where you would write your deployment scripts. Again, we're not going to run through how to do that, but just wanted to show if you wanted to deploy your contracts on chain, this is where you would essentially write your deployment scripts. And as you can tell, everything is in Solidity, your test, your contracts, and even your deployment scripts. So that's a pretty big benefit of Foundry. I guess we can briefly touch on remappings. I can't remember the remappings. Okay, that is how you do it. All right, so remappings is another way to shorten your imports. So essentially, if you needed to import, let's not go to the script. If you needed to import, let's say, a OpenZeppelin smart contract, instead of having to write the full import statement, you might have to like import ERC20, and you may have to do that from a file that's super long. You might have to go into lib, yada yada, you know. You have to go and pretty much type out this whole import statement that could be super long. Well, Foundry remappings allow you to shorten what this would be. So, for instance, this lib forge, std, lib, ds test, this is just some things you need for your testing. You can shorten that and just use ds-test. So that's another cool thing that Foundry allows you to do. It's just another interesting feature to allow you to write things fast and just quickly. Okay, now what about Hardhat? Although to some people Hardhat would be essentially new, this is an older framework, but we're saying older in comparison to Foundry. Foundry is newer. Hardhat is older than Foundry. Hardhat is also a framework for developing, testing, and deploying smart contracts. Some of the pros of Hardhat is that deploying and verifying contracts is seamless. We haven't necessarily touched into verifying contracts just yet, but when you verify a contract, you essentially publish it on Etherscan so that other people can actually see the contents of your contract versus just the bytecode of your contract. Also, many tools so deploying and verifying contracts is seamless. It's easy to integrate other tools with Hardhat. So there's VS Code extensions for Hardhat. There's the various plugins for dealing with your TypeScript code and for Hardhat. So this is just something that Hardhat is beneficial when using Hardhat is because it's been around for a little bit longer. So there's a little bit more support for this framework. Another pro is that it's easier if you are a front-end developer as well. The reason for this is because all of your tests are written in JavaScript or TypeScript, which is code other than Solidity. Some people may see this as a con, but if you are a front-end developer and you want to know how your contracts need to integrate with the front end, Hardhat is honestly perfect for this because you're going to be writing your test, and when you're writing your test, it's going to be in JavaScript, TypeScript, so that once you implement this in your actual front-end code, it's going to be a lot easier to plug and play because you can port over a lot of the functionality from this test into your front end. Now, a con is that it's not as fast and as easy to start testing Solidity code. Like we said, you have to know JavaScript or TypeScript, which is a language other than Solidity. So if you are someone who only knows Solidity, it may be a little bit hard for you to use Hardhat. Personally, I like to use Hardhat and Foundry together. So whenever I'm writing code or testing another developer's code, I will use Foundry to do all this testing. But whenever I am focusing on deploying my contracts and verifying them on chain, I will definitely be using Hardhat. And so yeah, it's pretty cool because you can combine these two together to get all the needs that you want. But it's going to be up to you after we demo both of these to figure out which one do you want to go with. Do you want to go with only Hardhat? Do you want to go with only Foundry? Or do you want to go with a combination of both? So that is the overview of Hardhat. We're going to jump into some demos here shortly. So we are back. We have everything downloaded, and as you can see already, there is a slight difference in the files that were created. So let's take a look at this more. All right, so they actually have a contracts folder for your contract. The initial contract with Hardhat is lock. They have node modules in here, so as some of you may know, to interact with various smart contracts, you're going to have to use these different plugins. But also to interact with the front end for smart contracts, you're going to have to use some of these plugins. You have your scripts. So here's our deployment script. As you can see, this is a little different. This is in JavaScript. It is not in Solidity. So this is essentially deploying this lock smart contract, I believe. Yes, this deploys this lock smart contract on chain. And you can see how this looks very different from Foundry's deployment script. And this is what a test looks like. Definitely a lot more involved. Now these are testing more things, but in terms of the things you need to import into this contract or into this JavaScript file is much different than what you would need to do with Foundry. The whole framework is just different. This is all in JavaScript. Everything we're doing here is in JavaScript, and we're making calls to these smart contracts to run our test. So essentially, in a setup for Hardhat, it's going to be locally deploying something, and then that's how you perform your test. So this is another thing that's really cool is you see how you can interact with events as well. So we have we can even test the events that our smart contract is emitting. So that's something that's very important when testing your smart contracts. The Hardhat config file is where you would throw some other details related to like your private key if you want to test on some local chains. You'd also throw in some of your API keys to interact with Etherscan. This is just a quick overview of how Hardhat is set up. And in terms of call stack tracing, I don't think there's really too great of an option to do that with Hardhat. Whenever I used to use Hardhat, I essentially would have to evaluate those transaction logs to see what I did wrong. I'd also have to do the old school, console log statements and just test individual things within my smart contract if I wanted to see what was going on underneath the hood. Also, the error messages were very important when trying to understand what I did wrong. So that is another thing that I don't think I mentioned in the PowerPoint presentation, but that is another thing that's not a con of Hardhat, honestly, is debugging is not as great as you would get in Foundry.